Hello class. So in this video, we will be discussing the first chapter, which is Introduction and Review of Logarithms and Decibel. So from the previous semester, we have discussed semiconductors and kung paano ba siya nag-work, pagkatapos paano ba natin sila ginagamit for purposes such as switching o kaya ay amplification. So in electronics 2, we will be going deeper na with semiconductors and mag-aaral na rin tayo ng mga ng mga semiconductors na more than 2 yung or more than 2 or 3 yung mga terminals natin kasi 'di ba last time we have discussed diodes lang tsaka transistors. So but in this semester medyo mas malalim na aaralin natin. So, di lang DC analysis, AC analysis din, kukombine na natin yung process nila, tapos i-analyze natin overall ano yung nangyayari. Also, mas mga complex na circuits, different types din ng circuit, tapos yung mga iba't ibang klase ng network, ano rin yung mga purpose nila. So, yun yung aralin natin dito. Now, yung analysis natin, for this, so this will extend through a wide frequency range. So kung nakaraan, hindi na natin masyadong pinag-aralan paano ba yung effect ng frequency. So this time around, pag-aaralan natin siya. So aside from that, pag-aaralan din natin dito is kung gaano ba kalaki yung improvement from one circuit to another or from one point to another in a circuit. Depende sa network na ginawa natin, tsaka sa mga semiconductor devices na ginamit natin. So thus, we will be dealing with a wide frequency range as well as a wide range of values of gain. Kasi di ba minsan meron tayong mga component or network na mag-increase yung gain natin ng 100,000s yung pag-increase ng value ng gain natin. So because of this, we will be using logarithmic scale. Yun yung aralin natin ngayon. In addition, because industry typically uses a decibel scale on its frequency plots, pati sa gain, the concept of the decibel is introduced in some detail. So in preparation for that, logarithms and decibels will be discussed in this module. So ang sabi dito class, sa mga specification sheets to be specific ng mga mga devices natin, di ba yun yung may mga characteristic curve, tapos titingnan natin yung bode plot nila or how does a certain component react to a wide range of frequencies. So, ang nire-represent yung figures na yon using decibel. So, kaya i-discuss din natin siya ngayon. So, review lang naman to basically kasi I know na-discuss naman na siguro yung logarithms before. So, familiar na tayo dun. Ayan. So, logarithms class. So, in mathematics, the logarithm is the inverse function to exponentiation. So, kabaliktaran siya ng exponent, kumbaga. That means that the logarithm of a given number, let's say x, is the exponent at which another fixed number, so the base, usually dinidenote natin siya as b, must be raised to produce that number x. Thus, if, let's say for example, we have number a, tapos, and it is equal to b raised to x, then kung i-inverse natin yung operation, dito, di ba kasi kinuha natin dito yung result, kumbaga, ng exponentiation, the logarithmic operation is like this. The exponent is equal to the logarithm of the base times a, or the logarithm of a pala to the base p. So this is how we represent logarithms. So if so the variables a, b, and x are the same in each equation. So if a is determined by taking the base b to the power x, then the same will result if the log of a is taken to the base b. So for instance, para mas madali nating maintindihan, lagyan natin ng numerical value. If b is equal to 10 and x is equal to 2, base natin is 10, x natin is equal to 2, then the result is equal to a. But pag binaliktad natin siya, we know that our a is 100, then we can get the value of x naman. So, ang x natin dyan will be, from the equation earlier, we have x is equal to log BA. then it is equal to the logarithm of 10 times yung a natin, which is 100 na nakuha natin dito kanina. The resulting logarithm will be equal to 10. That is equal to 2 to the base 10. So that is how we compute the logarithms. So in other words, if you were asked to find the number that would result to a particular level, such as 10,000, then therefore you need to determine the value of x. You can get that using logarithm. Just take the logarithm of 10,000. Tapos, ang base mo is, depende sa base mo is kung ano yung base ng na ni-raise mo kumbaga. So in this case, that is 10. Then you can get the answer. So ito yung kakalabasan niya, that is x is equal to log 10 of 10,000 is equal to 4. So ibig sabihin, if you raise 10 to 4, you will result to 10,000. Now, ba't nga ba natin siya inaaral? Because for the electronics industry and in the vast majority of scientific research, the base in the logarithmic equation is chosen as either 10 or the number a. So, kasi nga, ginagamit natin to kadalasan sa scientific researches, actually theoretical principles, etc. So, ginagamit natin tong mga to. So, ang madalas na base natin is base 10. So, ito yung common logarithm na tinatawag. And then base e, ito naman yung natural logarithm. Wherein e-class, that is an irrational number na equal sa 2.7182887, etc. etc. So, mahaba yan. Actually, walang katapusan since it's an irrational number. So, fraction lang siya. Next is, so logarithms, ano siya, hindi pala siya ma-express into functions. Kasi nga, into fraction. Kasi nga, irrational number siya. So, logarithms taken to the base 10 is referred to as common logarithms, as I've mentioned earlier. And the logarithms taken to the base e are referred to as natural logarithms. So, in summary, ito siya. So, log to the base 10 of a, that's common logarithm. Log to the base e, that is natural logarithm. So, the two are related by, so yung dalawang logarithm na to ay meron silang relation. So that is log e of a is equal to 2.3 ng log 10 of a. Now, on scientific calculators, the common logarithm is denoted by the log key and the natural logarithm is ln key. So, ganun din. Usually, kapag pinapresent yan sa mga solution, etc., kapag log lang yung nakasulat, that is understood na, that is log to the base 10. So, yung nasa calcul natin, that is log to the base 10. And kapag naman, ln, it means log to the base e. So, automatic na rin yan. So, hindi na natin yan inaano na, pag sinabing ln, sasabihin mo pa na base e yan. So, automatic alam na natin dapat yun. That ln is to the base e and log is base 10. So, kadalasan, kapag iba yung base, sasabihin naman yun. So, ito bawa ito to the base 3. So, dito mo palang i-assume na, this is not a base 10, but rather base 3. Base 3. Kasi nga, specified siya specifically. Now, ito yung importante about logarithm. It does not increase in the same linear fashion as the number. So, di ba, kapag hindi mo pa nilo-logarithm yung isang number or isang expression or isang value, kapag nag-increase yan, usually linear pa. Kasi algebraic pa yung pag-increase natin. Linear yung pag-increase niya. Pero di ba, kapag nag-exponent tayo halimbawa, pagka ba exponential yung ating isang function, linear pa ba yung curve natin, kumbaga? Hindi, di ba? So, syempre, if exponentiation is the inverse of logarithms or the logarithmic function, then therefore, hindi rin linear yung curve natin sa mga logarithmic na function. So, because the logarithm itself, the operation itself is not linear. So, that is, let's say for example, dalawang number mag-compare tayo. We have 8,000 tapos 64. So, yung 8,000 class, that is 64, this is 125 times larger than 64. So, ibig sabihin, kung from 64 to 8,000, nag-increase ka 125 times. So, you multiplied 64 to 125, you will arrive at 8,000. So, from a value na nandito sa side na to reach this side, kailangan mo mag-increase ng 125 times. So, ganun yung linear na natin, linear na pag-increase niya. However, pagka ni-logarithm natin yan, if we take the logarithm of 8,000, that is 3.9. From a value na 1, but the logarithm of if we take the logarithm pala of 8,000, that is 3.9. And if we take the logarithm of 64, that is 1.81. So, kung from 64 to 8,000, in a linear scale, 125 times kang nag-increase. Pero, kung titingnan mo, yung logarithms nila, from 1.81, naging 3.9 lang. So, mababa lang yung pag-increase niya as compared to this one. Pero same lang naman siya. This is logarithm 64. This is logarithm 8,000. Pero, yung pag-increase nung from 64 to 8,000, 125 times. Pero, yung pag-increase from logarithm 64 to logarithm 8,000 is 2.6 times larger lang. So, nakita, hindi siya linear. Magkaiba yung scale natin. So, this is a very, sabi nga dito, non-linear relationship. Kumbaga, pag nag-increase ka ng 1 time dito, hindi ka lang mag-increase ng 1 din sa logarithm. Iba yung pag-increase niya. Kung yung 64 naging doble, yung 1.81, hindi yan madodoble kapag dinoble mo yung value nito. So, that is the logarithmic relationship natin. So, pag tinignan natin tong table na to, makikita naman natin na kung paano ba yung pag-increase ng isang logarithm na value. Nag-increase siya as the exponent of the number increases. So, napansin nyo, at logarithm 0, or logarithm ng 10 raised to 0, so 0 tayo dito. Wala tayong 0 lang tayo. And then, from logarithm of from 10 raised to 0, so this is equal to 1 din pala basically. So from 1, naging 10, nag-increase ka 10 times, di ba? Pero nag-increase ka ng 10 times, pero from your logarithm, nag-increase ka lang ng 1. Next, ito, halimbawa from 10 to 100, logarithm of 10 to logarithm of 100. Nag-increase ka 10 times ulit. Pero yung pag-increase mo ng 10 times, nag-increase lang siya ng 2. So, naging log 2 lang siya, kumbaga. So, that is the relationship of, that is the explanation sa non-linear na relationship ng isang logarithm. Now, ang isa pang mapapansin natin dito, class, di ba, from 64, naging 8,000. Pero in logarithms, from 1.81, naging 3.9 lang. So, ito yung sinasabi natin kung bakit ideal gamitin ang logarithmic scale when it comes to expressing a wide range or a wide range of numbers or a wide range of frequencies. Kasi imagine niyo, class, kung lagi mong sasabihin na, from 64, magiging 8,000 volts, halimbawa yung output mo, or ang gain mo is nasa range ng 100,000s. So, hindi siya practical na isusulat mo. Ang gain mo is nasa ganitong value, nasa 100,000, diba? So, hindi siya practical kasi masyadong madaming numbers or masyadong maraming digits. Now, if ang gagamitin mo is logarithm, hindi ganun kadami yung hindi ganun kadami yung digits mo. Hindi ganun kahaba yung magiging values kasi in logarithm, imagine niyo from 64 to 8,000. Ang change lang 1.81 to 3.9. So kahit tumaas siya ng tumaas, hindi ganun kalaki yung magiging value natin. Hindi ganun kahaba yung kailangan natin na value na hindi kailangan natin siyang i-represent ng sobrang daming digits, kumbaga. So, kaya importante yung logarithms natin. Now, compare natin yung dalawang scale. Itong nasa baba is the linear scale, and then yung nasa taas is the logarithmic scale. So, ang pagkakagawa nito, class, meron daw tayong isang scale. Parehas sila. Yung isa, parehas na from 0.1 to 100. But the difference is, the first one is logarithmic, the second one is linear. So, paano nga ba nag-i-increase tong bawat value na to? So, kung makikita nyo dito, class, sa linear scale natin, pare-parehas yung distance ng bawat point sa isa't isa. Halimbawa, from 1 na value, papunta ka sa 10, you have, halimbawa, x na lang yan. Ganyan kahaba yung distansya mo from 1 to 10. Now, pagka ginawa din natin yan dito, from 10 to 20, yung distance mo is also the same. And ganun din yan doon sa mga, kung titingnan natin yung mas maliit na measurement. So, halimbawa, yung 10 to 11, same siya ng distance din from 1 to 2. So, kumbaga, linear yung relationship ng scale natin. Pero kung mapapansin nyo, with logarithm, that's different. So, from 0.1 to 0.2, ganito kahaba yung distansya natin. And kung mapapansin nyo, magkasing haba yung from 1 to 2. Pero ano ba yung common sa 0.1 to 0.2 sa 1 to 2? Ang common sa kanila, class, from a value of 0.1 and 1, na doble sila, naging 0.2 and 2 respectively. So, ganun, class, yung logarithmic scale natin. So, instead, natitingnan mo siya ng nag-add ka ng 1 plus 1 plus hanggang maging 2, nag-add ka ng 10, naging 20. Hindi natin siya ganun tinitingnan. So, tinitingnan natin siya from a reference point lagi. Kung from 0.1, naging 0.2 ka, gaano kalaki yung nilaki mo. So, kung napansin natin, from 0.1 to 0.2, na-multiply sa 2 yung value natin. So, kapag ganito kalaki, yung x mo, palitan natin na, huwag na x pala, para hindi ka malito. Let's say this is y. Yung distance nito, sa scale natin, from 0.1 to 0.2, ang ibig sabihin yan, class, nag-increase ng times 2 yung value mo. So, ganun din yan dito. Magkasing size yun, ito, from 0.1 to 0.2, magkasize sila from 1 to 2. So, ibig sabihin, class, if this is equal din sa y, kung ganun kahaba, ang ganyan kahaba sa logarithmic scale, it means na magta-times 2. Yung value, ng reference point mo, ng original value mo, magta-times 2 siya sa sarili niya. So, that's why yung 1 naging 2. Now, isa pang pwede nating makita dyan. Tingnan nyo. Yung haba ng from 2 to 4. 2 to 4 sa logarithmic scale natin, that is actually also equal to y. So, kung ganun yung case, from 2, magiging 4 yan kapag nag-move ka to the right ng kasing haba nito. So, kung gusto mong malaman, halimbawa, nasa yung 3 naman, gusto mong hanapin yung 6 dito. Para mahanap mo yung 6, mag-move ka ng kasing haba nito. Kasi alam mo na kapag nag-move ka to the right ng ganyan kahaba, nag-multiply sa 2 yung reference point mo. So, kung hanapin mo yung 6 dyan, bale, kung ito yung 3, mag-move ka ng ganito kahaba. So, approximately, mga ano yan, nandito. Mga nandito siguro. Kung ano ba kukunin, kukopyahin itong ganito kahaba. So, yan. Tansya-tansya lang. So, mga ganyan kahaba siguro. So, kapag ganyan ka, ay hindi. Sorry. From 3 dapat. So, kung gusto mong malaman, nasan yung 6? Para malaman mo kung nasan yung 6, kailangan mong mag-move from 3 ng ganito kahaba. So, kung ganyan kahaba, so kung dito ako magsisimula, so mga ganito. So, if this is, hindi, kulang pa. So, if this is your Sorry. Ayan. So, if this is your reference point na 3, diyan ka magsisimula, gusto mong malaman kailan siya madodoble. Mag-move ka ng kasing laki ng y. And ito, this is approximately kasing laki ng y. So, ibig sabihin, this will be the value of, this will yield a value of 6. So, ganun din yung iba. Kung gusto mong malaman from 5, ay wala palang 5 sa ano. Gusto mong malaman halimbawa from 4, ito na lang, from 0.4, gusto mong malaman nasan yung 0.8. So, kung gusto mong malaman yun, kopyahin mo lang ulit yung ganito kahaba, tapos hanapin mo siya dito. So, kung ganyan kahaba, equal sa y, so dapat nandito yan. So, if this is equal to y, then, yung nasa dulo niya, that is your 0.8. Kasi, from 0, a distance of y from one point to another means an increase of 2 times its value. So, ganun class yung nangyayari. Now, pag titingnan pa natin isa, try naman natin pag mag-increase ng 3 times yung value. Kung mag-increase ng 3 times yung value natin, then ito na lang nasa gitna gamitin natin. So, from 1 to 3, ganito siya dapat kahaba. This is our new y. Kung i-increase ka ng 3 times, so ganito kahaba dapat yung i-move mo from your reference point papunta sa kanan. So, halimbawa, gusto mong malaman ang 3 times ng 12. Yan, so medyo mahirap yun. So, you want to, ano na lang pala, the 3 times, hanapin na lang natin yung 90 pala. Kung magsisimula tayo at 30, gusto mong malaman yung 3 times ng 30, which is 3 times 30, that is 90. So, hanapin natin yung 90 dito. So, para mahanap natin yung 90, kunin mo yung ganito kahaba, and then mag-move ka from 30 to the right ng ganito kahaba, equal to y. So, that is, eto yan. If this is equal to y, then eto yung 90 natin. Now, dapat, sa kahit anong value, makuha natin yan. And dapat, kahit saan natin kunin, kahit ano yung reference point natin, mag-work tong, mag-work tong, mag-work yung, pag-move natin from right to left, and makukuha natin yung value na dinedesire natin. Like, let's say for example, ito, kasi itong mga kanina example ko may linya, di ba? So, medyo madaling ma-identify. Paano kung yung walang linya? Halimbawa, itong 4. Gusto kong malaman is kailan, nasan yung 12? Kasi di ba, pag yung 4, gusto mong malaman yung 12, wala siyan dito sa linya natin. Kasi, yung sa kanina example ko, pwedeng binubudol ko pa kayo eh. Kasi obvious, kasi may mga linya tayo, may mga markers tayo. So, alam natin kung nasan siya. Now, ang tanong, sir, paano po kapag wala nang ganun? Halimbawa, gusto kong mahanap nasan ang value ng 12. So, to find the value of 12, dito sa scale natin, nang wala tayong markings, marami tayong paraan actually, pero ang na-discuss natin is, pwede tayong mula 6, so this is 4, 5, this is 6, pwedeng mula 6, mag-move tayo ng equal dito sa movement natin from 1 to 2. Or movement natin na madoble. Kumbaga na pagdoble ng isang value, pagdoble ng isang reference na value. So, mag-move tayo pwede ng equal dito. Or pwede naman na from 4, mag-move tayo pa right na equal naman sa kasing haba nito. Let's say this is y sub 2. So, either dyan, napiliin natin kung saan tayo magfo-fall after nating mag-move tayo ng kasing haba ng kahit alin dito sa dalawang to from their respective na reference point, dapat makuha natin yung 12. So, let's say, for example, mag-move tayo ng equal sa y sub 2 from 4. So, ang mangyayari sa class, kung kukunin natin ito, hindi ko alam kung paano ko siya makukuha ng ganun kahaba. So, tatansyahin ko lang. So, mga andito siya hanggang dito. So, this is equal to y sub 2. So, kung tama yung measure ko, andito yung 12 natin. Pwede rin naman na from 6, kasi alam natin na pag nadoble ang 6 magiging 12, from 6, mag-move tayo ng to the right ng equal sa y sub 1. So, mag-fall pa rin tayo dapat sa 12. So, ganun class yung logarithmic scale natin. So, isa pang mapapansin nyo dyan, may very obvious din tayo nakikita, na every time magiging times 10 yung isang value, mag-move tayo ng ganito kalaki. Let's say this is your y sub 3, yung haba niya. So, mag-move tayo ng ganito kalaki. So, if you want to know nasan yung times 10 ng 1, edi mag-move ka ng y sub 3 to the right. Gusto mong malaman yung value ng, halimbawa, gusto mong malaman yung value ng 40. So, from 4, alam mo na multiply yan sa 10, mag-move ka ng equal sa y sub 3, then that is the value of 40. So, pati yung mga unknowns dyan, halimbawa, hindi nyo alam kung nasan siya makikita. Pwede nyo gamitin tong ano na to. Gamitin yung ganung way pa rin para mahanap. Now, kita class na very different yung pag-move nung mga values natin compared to linear. So, sa linear, equally spaced sila lahat from relationship natin na 1, pag nag-add ka ng 1, all throughout, ganun lang yung movement to the right ng ating linear scale. But sa logarithmic scale, hindi ganun. So, in your module, may exercise nito and also part siya ng ng submission. So, para ma-apply nyo siya doon. Ayan. So, next naman, we have decibels. So, decibel class, it is a unit used to measure the intensity of sound or the power level of an electrical signal by comparing it to a given level, tapos naka-logarithmic scale daw tayo. So, kaya natin inaral yung logarithms. It's because yung mga parameters natin in electronics, that's very important, such as gain, ay ina-express natin sila in decibel. Gain, power level, etc. So, na-express natin siya in terms of decibels. So, it is generally used to express the degree of loudness of sound, but it is also extensively used to describe sound level. So, decibel daw, it is a measure that is always in comparison with the reference value. So, laging may pinagkukumparahan tayo dito. Hindi siya unit na parang katulad ng meters, halimbawa, na pag sinabi mong 1 meter, that's 1 meter. Pag sinabi mong 1 decibel, meron kang pinagkukumparahan dapat. From a point, that is your reference point, you have 1 dB na value from your reference point. Laging ganon. Hindi pwede na wala tayong reference point. At least, ang reference point natin halimbawa is from 0. So, from 0 to another value, gaano laki yung increase mo in decibel. So, ganun lagi yung computation natin. Mas maintindihan natin yung mamaya. So, when the parameter is equal to the reference value, the decibel level is 0 dB. So, yung decibel class, in-express natin siya as dB. At kapag daw, yung parameter mo, let's say for example, voltage mo ay 1 volt. Ayan. Kung yung 1 volt na yan, pumasok sa loob ng circuit at paglabas niya, 1 volt pa din siya at gusto mong gamitin yung dB to compare the value or the output nakakalabasan nung yung voltage after passing through the circuit, it is equal to 0 dB. Kasi ang sabi dito class, kapag equal ang reference value, the decibel level is 0 dB, meaning walang nangyari. Halimbawa, may tanong sa inyo, meron akong signal dyan, pinasok ko dito sa circuit. Paglabas, ano na yung sound level? Or ano na yung level ng voltage ko? So, ang sasabihin mo, 0 dB. Kasi, same pa rin siya, na from pumasok siya 1 volt, paglabas niya, 1 volt pa din. Now, if the value naman is mataas, so kung mas mataas yung output mo kaysa sa reference value mo, halimbawa, from 1 volt, naging 2 volts yung value mo. Then, nagkakaroon tayo ng gain. And yung resulting gain na yon, ang equivalent niya sa decibel is a positive na value. So, we'll have a positive decibel value. If the value naman class is lower than the reference value, negative yung makukuha natin. Like let's say for example, from 1 volt, biglang naging 0.5 volts. Ang mangyayari class, meron tayong attenuation, and ang result nun na logarithm na value or decibel na value is negative. So kapag nagbago yung value mo, tumaas, ito katulad dito sa point na to, kapag tumaas, you will have a positive na value ng dB. Kapag parehas lang, hindi nagbago, you will have 0 dB. Kapag naman bumaba from your reference point, that is a negative na value ng dB. Now, why do we use decibel in electronics? So the term decibel has its origin in the fact that the power and audio levels are in logarithmic basis. Meaning, yun daw nature ng power, ng sound, kung paano natin sila na-perceive, that is logarithmic in nature. Hindi siya linear. Paano ibig sabihin doon? Halimbawa, meron ka daw increase in power from 4 watts to 16 watts. So, in the linear na scale, nakita nyo class, 4 times, di ba, yung pag-increase nung power natin. From a power, ang reference point natin is 4 watts, nag-increase siya to 16. Ilang times nag-increase siya in the linear scale? 4 times. Diba? 4 times siyang nag-increase. However, hindi ganun hindi natin siya ganun naririnig. So, hindi natin siya, kumbaga, hindi yan magre-result na kapag nag-increase yung power mo ng 4 times, lalakas yung tunog niya ng 4 times. Hindi ganun. Our perception is different. Rather, ang perception nating class, from 4 watts to 16 watts, yung naririnig nating tunog is lalakas lang siya ng twice. So, 2 beses lang siyang mas lalakas. So, hindi siya lalakas ng 4 times. Lalakas lang siya ng 2 times. Yung 2 times na yon, which is actually the relationship of a logarithm. Kasi, kung titingnan nyo class, kung ito yung base natin, ito yung x, ito yung a, para ma-reach mo from your base, ma-reach mo yung a, you need a logarithm of 2. You need to have an exponent of 2. And that is what we take in logarithm. So, ibig sabihin, nag-increase siya equal so kung paano nag-increase in logarithm. Not kung gaano siya nag-increase kapag linear yung tinitingnan natin. So, for a change, halimbawa, next, for a change of 4 watts to 64 watts, di ba ano yan? So, 4 times 4, 16 times 4, 5 times siya mag-i-increase yung value ng power. So, 5, hindi pala 5 times, 6 times pala siyang mag-i-increase. Now, hindi yan 6 times din lalakas yung tunog. Lalakas siya ng 3 times lang. It will increase, the sound will increase by a factor of 3. Because we have 4 cube is equal to 64. If this is your base, and this is, ito yung kinalabasan mo, from 4 to 64, the actual increase is the exponent to get there, which is 3. So, in logarithmic form, pati yung nasa kanina, pwede natin silang express as ganito. Kasi nga, ang base natin dito is 4. Pero ang increase niya class is equal dito. Nakita? So, anong function yung ginamit natin to get kung gaano kalaki yung increase niya in sound na na-perceive natin? Hindi naman yung linear scale, di ba? Ang ginamit natin is logarithms. So, to put simply, it means that an increase of power from 4 watts to 16 watts would result to perceiving the sound twice its original loudness. And an increase of power from 4 watts to 64 watts would result to perceiving thrice its original loudness, and so on and so forth. So, kaya class, ginagamit natin yung decibel because it is easier for us to express since similar in nature kung paano natin siya na-perceive. Now, yung decibel natin class, or yung gain natin rather, so G natin class is the gain. In terms of decibel, we can express this in this form. In terms of bell pa lang pala muna, bell lang yung tinutukoy natin. We can express this as this form. So, ang gain natin, alam naman natin yan, lagi yan, it is the ratio of the output to the input. Let's say ang output natin is P2, then ang input natin is P1. So, that is our gain. So, ganun kalaki yung ini-increase nung signal natin from P1, nagiging P2 siya. So, ganun kalaki yung factor ng increase niya. So, if we want to take the logarithm, o the ilog lang natin to the base 10, ito yung result. Kapag ganyan class, ang tawag natin sa unit na yan is Bell. Bell coming from Alexander Graham Bell. So, again, Bell is a unit of level. And that is with reference always to another value. So, in this case, sino yung reference natin? Ang reference natin is P1. From P1, from P1, naging P2 siya. So, gaano kalaki yung increase? Ayun. So, level of increase yung tinag-uusapan natin. Now, let us say, for example, the power will increase twice the value of P1. So, therefore, yung P2 natin, magiging doble daw eh. So, P1 magiging doble ng P2. Magiging doble, magiging equal siya sa P2. So, P2 natin is twice of P1. So, substitute natin dun sa equation. We will have log G is equal to log of 2P1 over P1. So, makakancel yung P1. Matitira na lang is log 2. Parang tulog lang. So, kapag kinalki natin tong log 2, we will arrive at 0.301 Bell. So, ibig sabihin, class, kung meron kang circuit at sinabi ng circuit mo na ang gain niyan ay equal sa 0.301 Bell. Ano ibig sabihin nun? Ibig sabihin ng class, yung input signal mo, mag-increase yan ng twice its original value. So, ganun class yung interpretation natin doon. So, ibig sabihin class, naging doble yung value ng power mo, pero yung bell mo is nag-increase lang ng 0.301. So, kung gusto mong malaman, halimbawa, 4 times naman yung increase nito. Kung 4 times yung increase niyan, doblehin mo lang to, kasi madodoble ng 2 beses, di ba? So, that is, at 0.602 bell, yung input signal mo, magiging 4 times siya. Yung output signal mo, magiging 4 times siya nung input signal mo. So, ganun class yung kung paano natin inaaral to. Ina-apply. And, hindi rin siya ganun ka, di ba? Hindi rin siya ganun ka practical gamitin. Bakit? Kasi isipin mo, tumaas na ng 4 na beses yung value ng input signal mo. Pero, decimal pa rin yung output mo. So, medyo nakakalito kasi decimal, ibig sabihin, hindi ka nga magpa-500, 1,000, etc. ganyan. Kaso, puro ka naman 0.0, point, ganyan. So, kung ganun yung case, hindi rin siya ganun ka daling gamitin. So, ano yung pwede natin gawin? So, ang gawin natin, multiply natin siya sa 10. So, kapag minultiply natin siya sa 10, so, hindi pala to mumultiply sa 10. Ang ibig ko sabihin, class, ma-observe kasi natin na yung bell itself, masyado siyang malaki na unit of measurement and hindi rin siya practical. Kasi kaya nga tayo nag-logarithm from the first place para maging practical. Tapos hindi naman pala siya maging practical din. So, ang ginawa natin, instead of using bell, what we use is decibels. So, yung decibels class, pag sinabi nating decibel, para lang din siyang pag yung mga measurements natin, di ba, meter, may centimeter, decimeter, etc. Sa mga units natin, metric na unit, sa, halimbawa, di ba, ang 1 meter, tapos meron tayong centimeter, that is, we have 100 centimeters equal to 1 meter. So, kapag naman decimeter yung pinag-usapan natin, 10 decimeters, that is equal to 1 meter. So, yun na lang yung gamitin natin dito. So, to use that, instead of naka-bell tayo, gusto natin na unit natin is maging decibel, ito class yung formula natin or expression. We have 10 log of P2 over P1. Ang resulting na niyan class is now dB. Hindi na siya bell lang. So, kung ang isang bell kung ang 0.301 bell signifies the original value to twice nito, ano kaya yung 0.301 bell in decibel? E di multiply mo lang sa 10, that is 3.01 dB. So, yung 0.301 bell, this is equal to 3.01 dB. 3.01 dB. Parehas yan, na kapag yan yung nakalagay na level ng isang circuit, ang mangyayari dyan class is madodoble yung value niya. So that is decibel. Now, in-express natin class yung power natin in terms, yung gain natin of power in terms of power din. Pero pwede rin natin class na hindi in terms of power, in terms of voltage yung gamitin natin. Because sometimes in circuits, mas tinitingnan yung voltage gain kaysa sa power gain. So kung ganun class, palitan lang natin yung P ng in terms of voltages. Kasi di ba we know that V class or voltage natin, naiba to. So this is supposedly V squared over Ri. So because we know class that power is equal to V squared over R. So kung in terms of voltage yung binigay sa atin, which is madalas yun yung case, kasi nga mas depende sa circuit na tinitingnan natin, pwede natin siyang palitan. And kapag pinalitan natin siya class, we will arrive at this equation. Since isa lang naman yung system, parehas lang ng resistance yan. So, Ri equal din sa Ri. Kasi baka nagtaka kayo, sir, ba't hindi po R2 tsaka R1? Since isa lang yung system na pinag-uusapan natin, that's just R1 parehas or Ri na lang parehas. So, makakancel ngayon to. Ang matitira na lang class is V squared, V sub 2 squared over V sub 1 squared. Pwede nating ilabas yung exponent. Mapupunta yan dito. Now, rules of logarithm class, yung exponent nito, pwede mo siyang gawing coefficient ng logarithm. In the same manner, yung 10 na to, pwede niyang maging, pwede siyang maging exponent nito. Pero, syempre, para mapadali, itong 2 yung ilipat natin. So, yung 2 na to, magiging coefficient. So, we will have 20 log, we have the gain in dB is equal to 20 log to the base 10 ng V sub 2 over V sub 1. So, halimbawa, given ka ng P2 tsaka P1, tapos given ka rin ng V2 tsaka ng V1, dapat kahit alin dyan sa dalawang yan yung gamitin mo, same na power gain yung, same na, masosolve natin na GdB or gain in dB, same dapat siya na value. Kung ito yung gagamitin mo, or ito, as long as given ka nung lahat ng parameters na hinahanap, na kailangan natin. Example. So, ito sabi, find the magnitude gain corresponding to a voltage gain of 100 dB. So, solution natin class, meron ka daw 100 dB na gain. So, ano daw yung magnitude? Magnitude gain. So, syempre, kunin muna natin yung gain, magnitude gain natin kumbaga, like the raw na hindi pa naka-dB level. So, to put that, napaka-simple lang. Kasi binigay na sa yung voltage gain, that is 100 dB. So, we will have 20 log of V2 over V1 that is equal to 100 dB. So, ang makukuha natin dyan class is the value nito. Pero hindi natin makukuha yung V2 tsaka V1 exactly. Kung ano yung V1, ano yung V2, hindi natin makukuha. But what we can get is this value. And we know class that V2 over V1, that is your voltage gain. So if you do that, ang usually ginagamit natin dito class, shift solve lang kayo sa calcu. So what you're going to do is just type everything on the calculator. So ito yung paano nyo siya type mismo. 100 is equal to 20 log. So pag nag-20 log kayo, lalabas dyan yung may ganito sa calcu. Tapos, gawin nyo na lang, lagay nyo is x. And then, press shift, tapos press solve, then press the equal sign, lalabas na class dyan yung value nito. So, if you do that, we will arrive class at 10 raised to 5 or 100,000. So, therefore, yung magnitude class ng system natin, mag-i-increase siya ng 100 times. compared dun sa input na value niya. So if you want to get the output, it is equal class to the input times the gain, which is, in this case, 100,000. Yun. So, yun yung gain ng pag-gain nitong magnitude natin. Pag-gain ng V1, para makarating siya sa V2 paglabas ng circuit, ganito kalaki yung increase niya. So, yun class yung solution natin for this problem. Another example, the input power to a device is 10,000 watts at a voltage of 1,000 volts. The output power is 500 watts and the input impedance is 20 ohms. So letter A, find the power gain in decibels, and letter B, find the voltage gain in decibels. So magkaiba yung hinahanap sa atin. Tapos this time, medyo mas komplikado na yung problem natin. So for letter A muna tayo. Now for letter A, kapag nalilito kayo, hindi nyo alam ano yung gagawin, bakit parang hindi ko alam, halimbawa hindi natin alam ano ba yung magiging value, ano ba yung hinahanap. Ang gawin natin class, lagi nyo tingnan based from the given, ano ba muna yung mga pwede nyo makuha na value. So given yung input power, given yung output power. So for letter A, very specific, pinapahanap sa atin is the power gain in decibel. Power gain in decibel. So direkta, pwede natin gamitin yung equation natin because we know that our gain in dB is equal to 10 log of the output power over the input power, or kanina this is just P2 with respect to P1. So apply lang natin. So we will have the gain natin in dB that is equal to 500 watts then to 10 kilowatts, the input power. Okay, sorry, mali pala yung ano. This is supposed to be the output. And this is the input. Ayan. Pasensya na, mali ang type. So, kung ganyan class, hindi, tama. Joke lang. Ano ba yan? So, sorry sa error class. Nalito ako. So, yun. The output power is 500 watts. Tapos, the input power is 10 kilowatts. So, ibig sabihin class, anong ina-expect natin na sagot dito? Dapat negative. Bakit? Kasi, attenuation yung meron tayo. From 500 watts, ay from 10 kilowatts, bumaba yung input, ay yung resulting power natin to just 500 watts. So, ito, type nyo lang din sa calculan, diretso, 10 log 500 over 10K. We will have negative 13.01 dB. This is our power gain ngayon. Next, ang question class is, what is daw the voltage gain in decibel? So, kapag voltage gain yung pinag-uusapan, ito na ngayong class yung gagamitin natin. So, we have, for letter B, the gain in voltage natin that is equal to 20 log ng V out, ng output over input. So, now, ang tanong, sir, hindi naman given ano natin, yung ano ba to? Given yung input voltage, sir, pero hindi naman given yung output voltage. So, how can we solve for the output voltage? Pwede natin gamitin yung power tsaka yung resistance natin. Because we know that P is equal to V squared over R. Meron kang given na P, meron kang given na R, then pwede mong gamitin yung formula na to. So, we will have V is equal to the square root of PR. So, that is your voltage. So, kunin natin yung gain natin in voltage. Take note, GV to. So, that is equal to 20 log of the square root of 500 watts times 20 ohms over 100 volts. So, watts per ohms is volts din. So, we will arrive at negative 20 dB. So, yan. So, take note class. Linawin ko lang kasi baka mali yung sabi ko kanina or malito kayo sa sinabi ko kanina. So, kapag power yung kino-compare natin, what we will get is the gain, na power gain syempre. But this time around, we are using the voltage gain. So, ang makukuha natin na value is the voltage gain as well. Ayun. So, that is how we use decibels when it comes to measurements. To measuring levels rather of parameters in electronic circuits. So, ayun. So, dapat is ma-familiar tayo doon kung paano natin siya ginagamit. So, solve nyo lang again yung mga exercises na nasa module natin. Now, kapag cascaded yung mga stages natin, i-discuss pa naman natin to ng more extensive pagdating ng other chapters. But, pahapiawan na natin ngayon since part siya nung sa nasa module kasi natin. So, for multiple amplifier stages, di ba, yung gain natin is minumultiply. So, halimbawa, meron akong dalawang amplifier. Tapos, meron akong signal dyan na papapasukin. Let's say, V1. Now, lalabas yung signal ngayon dito. That is, let's say, for example, may V2. Kapag may dalawa kang amplifier, let's say yung amplifier na to, tataas yung value mo ng 10 times. Yung amplifier mo naman na to, tataas yung input mo ng 2 times. So, kapag yung input ko na V1, pumasok dito, so mag-increase siya by a factor of 10. So, yung lalabas na output ko dito is V1 increased to a factor of 10. Or in short, 10 V1. Now, yung 10 V1 ko, siya yung input ngayon for the second stage. Na i-increase niya yung input ko by 2. A factor of 2. So, ibig sabihin, 10 times mo siyang in-increase dito, tapos i-increase mo pa siya ng 2 times, ang lalabas dun is 20 times nung V1. And that is your V2. So, ito yung explanation dun. Ito yung expression natin for that. Yung total na gain natin, nitong buong system na to, let's say that is 80, that is equal to the product of the magnitude gains. Pag sinabi kong magnitude gains, yun yung raw na gain, yung factor siya. However, these gains can also be expressed in dB. Now, kapag ka naka-dB yung gain mo, halimbawa, ang gain ko dito is 10 dB. Tapos, ang gain ko dito is 3.01 dB. If ganyan yung case class, instead na i-multiply mo yung 10 dB sa 3.01 dB, ang gagawin natin is i-add mo sila. So, yung expression natin, this can be simplified as the gain in dB, the total gain in dB is equal to the summation of the individual gains of each stages in dB din. Ayan. So, ganun class yung mangyayari. So, madali lang. So, actually, ito, sakto to. Tama itong ginawa ko na to. Yung 10 na increase, equivalent yan sa 10 dB. At yung 2 na increase, equal yan sa 3.01 dB. So, kung ganun yung case class, dapat pala, pag pinag-add ko to, equal yan sa pag minag-multiply ko to at nilogarithm ko siya. So, in short, dapat class ay equal yan sa 10 log ng product nito, which is 20, dapat equal yan sa 10 dB plus 3.01 dB. Kasi, log 10 is 10 dB and log 2 is 3.01 dB. So, ang kalabasan niyan, class, is 13.01 dB. Kapag pinindot nyo to sa calcu, ang lalabas din dyan is 13.01 dB. So, kapag pala nag-increase ka ng 20 times, equivalent yon sa increase of 13.01 dB. So, yun yung decibel value. Yun. So, that is our discussion class for this chapter. Now, para mas ma-practice pa tayo, yun, sagutan natin yung mga exercise na binigay ko. So, yun lang.